Then we found out the growth of white stream, if you use a microbubble, is about 30%. 30%. And then that is not enough. Then we moved to ISB, where we had much larger ponds or tanks.
Assalamualaikum and hi guys. Tiny bubbles with big impacts. Today's research is all about microbubbles. Interested to know more about this tiny fella? Let's go with me to meet Prof Poo Balan to learn more about this microbubble. Let's go.
My name is Professor Poo Balan from Mechanical Engineering, Faculty of Engineering. So today I'm going to brief about my project, which is called Microbubble Generator. One of the biggest challenges that aquaculture is facing is a lack of aerations. When we talk about aerations, normally daytime is okay, but comes at nighttime where there's no photosynthesis. The DO means dissolved oxygen, drop to below 5. And the value of dissolved oxygen below 5 is not a healthy condition for any culture in a pond. So in order to overcome these challenges, we are coming up with a specific technology where we can create a mixture of air and water using a specialized design nozzle. The main things about the geometry is there's a 2 input where there's water coming in on this side and the air coming in on the top part of the nozzles. And then the mixture is actually generated within the geometry, the inner geometry of the nozzle, where the discharge after mixing air and water will come out from the other corner of the nozzles. So basically, this is a nozzle part. Of course, this nozzle will be connected to a pump where it sucks the water and push it through these particular nozzles. Basically, the one that you see from the top, this is where the hair goes in. Water is coming from the pump, and then the discharge, you can see the bubbly discharge, which is sprayed into the pond where there's a culture, maybe fish or shrimps, whichever culture that you are culturing. So the benefit of such aeration technology is there are some horizontal transfer of the air which carries the oxygen from one side to the other side of the pond. And with this such a mixing, we hope we can deliver the oxygen and air throughout the pond. So it started from very fundamental bubble, just a bubble, simple bubble coming out from the nozzles. Then we do some CFD works, and then gradually we translate that bubble rising research into a nozzle type of flow patterns. Then we found out the growth of white stream, if you use a microbubble, is about 30%. 30%. And then that is not enough. Then we moved to ISB, where we had much larger ponds or tanks, water tanks. We test it again, because if you test it in a smaller scale, you cannot define the efficiency very well. Then you test it in a bigger scale. Again, we saw the growth is again 30%. There's some big facilities. I built it built by myself in the ISB. It's a bigger tank. It's almost like 4 meter by 2 meter tank. Again, we test it, but this time we use udang gala. Again, we notice the growth is significant. However, it's not 30%. It's reduced. Luckily, we signed some MOU where I have managed to continue my work with FRI, where the new work will be installing the prototype in FRI Galambata. We want to expand the aeration system also for water waste treatment, including POME. POME is a palm oil wastewater. So they have a lot of wastewater which need to be treated before can be released to anywhere. So this technology goes very well for POME, for water waste treatment, even in Shabash, and as well for aquaculture.
I've never known that those tiny bubbles can be very beneficial for our aquaculture. So I hope you guys learn some more from this video. So please give us some likes and then leave some comments for us. Bye bye!